Hello everybody, we're going to continue our videos on section 18H about the definite integral with some examples. So we're going to use the fundamental theorem of calculus to find the area between the x-axis and each of these curves. Remember that the fundamental theorem of calculus says that if I want to find the area between x equals 1 and x equals 3, I take the integral from 1 to 3 of this function, okay? And I find, then I evaluate it at when x equals 3, and I subtract the value when I evaluate it at x equals 1. So the integral of this function, hopefully we're feeling a little bit more comfortable with that now, is x to the 3 over 3 plus 3 times x to the 2 over 2 plus 2 times x. And now I need to evaluate it at 3 and 1. This is just some notation. These big square brackets indicate that now I want to evaluate. First, I want to sub in 3 to every place I see x, and then I want to subtract what I get when I sub in 1 to everywhere where I see x. So I'm going to have 3 cubed over 3 plus 3 times 3 squared over 2 plus 2 times 3, and I'm going to subtract 1 cubed over 3 plus 3 times 1 squared over 2 plus 2 times 1. And I'm going to keep these brackets because I do want to remember that I'm subtracting this whole function, not just this first term. So I've got to remember to apply that negative to everything in the brackets. So I simplify, and I reduce fractions where I can, collect like terms, and I end up with 74 over 3. I can also do this with a radical function. So again, if I want to find the area under the curve of root x between x equals 0 and x equals 2, I can take the integral between 0 and 2 of root x dx. It would help if I rewrote this in exponential form. Then I can see that using the power law, that the integral is x to the 3/2 times 2/3. Okay, remember, add 1 and add 1 to my exponent, so that gives me 3/2, and divide by 1 over 3/2, which is the same as multiplying by 2/3. Then I'm going to evaluate at 2, so I'm going to get 2/3, 2 to the 3/2, minus, evaluate this when x equals 0, which is just 0, I end up with 2/3 root 8. Now this could be rewritten. Remember that radical 8 can be rewritten as 2 root 2, because that's the root of 4 times 2, and the root of 4 is 2. So we end up with 2 root 2, and simplifying we get 4 root 2 over 3. Finally, if I had y equals e to the x, and I wanted to find the area under the curve between 0 and 1.5, I would take the integral between 0 and 1.5 of e to the x dx. Remember that the integral of e to the x is just e to the x, because it is its own derivative. And then I evaluate it when x is 1.5, and when x is 0, I subtract my results, and I get approximately 3.48 with 3 significant digits. The reason I used my calculator and got a decimal here and didn't keep it as an exact value is because they already gave me a question with decimals. So I'm going to stay. If they gave me decimals already, I can give them back an answer in decimals. All right. The last thing, which I'm not going to go through in much detail, is an example about using the fundamental theorem of calculus to just show that the integral of a negative function is the same as a negative version of the integral of f of x. It's really proving that if I pull out this constant, I still get the same answer. Okay, and just notice that y equals negative f of x is a reflection in the x-axis. So if this is my original function, if I reflect it through the x-axis, I get that, which means this shaded area here is negative because it's under the x-axis. If I reflect it, my area will be positive. Okay, if I reflect the function, I'm also reflecting the area. And this is me just applying that fundamental theorem of calculus. All right, thank you and have a great day.